B, C, that if we find the points, the midpoints of two sides, so here's the side BC, let's find the midpoint here, and the side AC, let's say the midpoint's around here, and that we draw the line through them two midpoints, okay, that this line here is parallel to the third line, okay, that's what the mid-segment theorem tells us. Now, the mid-segment theorem, okay, has a converse. There's a converse to the mid-segment theorem, and what the converse says if we draw a line parallel to any side through a midpoint of one of the sides, okay, that this line extends through to this line. So let's say the converse, okay, the converse of the mid-segment theorem, okay, effectively tells us, okay, so I've got two things going on here. This is meant to present the mid-segment rationale behind the mid-segment, okay, theorem, right? And then I really want to present the rationale behind the converse of it over here, okay. So what the converse says is that I suppose a straight line drawn through the midpoint of one side of a triangle parallel to another, okay. So let's draw a triangle. Here we go. Here's a triangle, A, B, C, okay. So what it says, a straight line drawn through the midpoint of one side of a triangle. Let's say here's the one side. So a straight line drawn through this midpoint, okay, parallel to any other side. So let's say parallel to the side AC, okay. So through the midpoint of AB parallel to AC, we're going to have a line that's going to be produced through here, okay. And what this converse of the mid-segment theorem is actually telling us is that this particular point, when extended through, intersects or bisects the third side. So let me just say that maybe once more. Is that a straight line drawn through the midpoint of one side of a triangle, AB, okay? Here's the midpoint here. A straight line drawn through it, or many straight lines that could go through that particular midpoint, but a straight line drawn through a midpoint of a side of a triangle parallel to another side, that when this is extended through, that this bisects, okay, this third side, okay? And that's what we're going to rely upon here, is the converse of the mid-segment theorem. And what we're going to do is we're going to extend a line through the midpoint, okay? Let's assume M is the midpoint of this particular triangle here, okay? We're going to extend the line through it, okay? So parallel to this third side AC. So we're going to extend the line through here, parallel to this third side. And what the mid-segment theorem tells us is that this line here will bisect this particular angle here. So it'll bisect, so not the angle, it'll bisect this particular line here. Now hang on. We know the coordinates of C, okay? The coordinates of C here, okay, are, well, it's on the horizontal, onto this horizontal line that goes through 2, 1, okay? So its coordinates, and it intersects this vertical line that goes through B that's parallel to the y-axis. So the coordinates of C are 4, 1, okay? So they're 4, 1, okay? Now, so we now know the distance. We now know the distance between here and here, okay? The distance between here and here, this length BC, the distance is 4 minus 1, okay? That's 4 minus 1. So hence, this coordinate here is half of this distance above the point C, okay? So in other words, this particular coordinate here, okay, is half of the distance up, okay? And similarly, if we do the same thing, if we take the midpoint of, let's say, of this particular line segment here, AC, okay, or let's say we have this particular midpoint that we want. If we draw a line parallel to BC, okay, so if we draw a line parallel to BC, what I'm saying is that this, through the converse term, is that this intersects this line here, and that these two lengths here are the same, okay? Okay. Well, let's think about it. So now we can actually calculate all of the coordinates of these particular parts of the triangle. So what I'm going to do is I'm just now going to start to generalize. Okay? So let me take this here. I'm just going to generalize now to let's say a larger triangle, okay, with coordinates x1, y1 and x2, y2. So let me create an xy axis. Okay. So let's say here we have an xy axis. I'll create this a little bit bigger so that it's a little bit more helpful. Okay. And let's say that we have a point in space here, A, and it's symbolized by x1, y1, okay, and we have another point in space here, let's say B, represented by x2, y2. Okay, and what we do is we produce a line. We have a line segment, so we have the line segment between these 2 points. Okay, and what we want to